Okay, we're going to go ahead and start chapter 8 today. Chapter 8, as our title explains, we have equations with two variables. So far, we've had things like this, where we've had one variable and we've solved for that one variable. Okay, so if we were to graph it, it would just point on a number line, so on and so forth. Now, what we're going to do is give you an equation that has both x and a y. And the reason we have both x and a y is so we could graph it. This one, I'm going to graph it, and you're not going to have to worry about it yet, but basically our graph would be something of this nature. It's going to go that direction. Eventually, in the next couple of weeks, we're going to show you how to get that graph. Today, what they're going to do is we're going to take an equation, not necessarily this one. Well, actually, it was that one. And they're going to say, they're going to give you possible choices for points. They're going to say, state whether these are solutions. These word pairs are solutions to this equation. So the solution means we're going to have to plug both numbers in and figure out if it makes a true equation. So this, we know the first letter or first number is which letter? X and then Y. So it's always X, Y. So we're going to substitute in 4 times 4 plus 3 times negative 2. 4 times 4 is 16 plus negative 6. What is 16 plus negative 6? 10. So does 10 equal 10? Yeah. Yes. So that one does work. It is possible we can get more than one, so we need to go through and try them all. Because if you think about a line, I mean, you could have endless numbers of points, so we need to check them all. 4 times negative 2 plus 3 times 6. That gets us negative 8 plus 18, which is 10. 10 equals 10. So that again is yes. Okay, so we have 4 times 3 halves plus 3 times 4 thirds. You know, that'll go in twice. 2 times 3 is 6. This will, the 3's will cancel out. This 3 to be now, so it's 4. What's 6 plus 4? 10 equals 10. Again, that's yes. And then the last one, 4 times 3 plus 3 times negative 1. Correct? Yes. So 12 plus negative 3, which is 9. Does 9 equal 10? No. No. So we had, of those 4, 3 of them did work. So 3 of them were solutions. Let's go through and do a different type of example. So this one, it says to solve. Basically, if they give you no information, like the last one, it gave us points. If they give you no information, this is where we're going to make basically a t-chart. So we've made the letter T. So you get to choose your values for X. I would always start with X. It's going to make your life simpler. Simplest ones, the best ones to choose, not necessarily the best ones, but the simplest ones to choose are things of this nature. Because they are small numbers, and zeros and ones especially will make your multiplication easier. So let's start with 0. We plug it in for X. We get 0 plus 1. What's 0 plus 1? 1y equals 3. So we divide by 1, y equals 3. 1y equals 3. So now we try it for 1. Plug in 1 plus 1. So 2y equals 3. Divide by 2. Y equals 3 halves. or 1.5. And our last one, we can do it for 2. 2 plus 1. 2 plus 1 is 3. Divide by 3, y equals 1. So now, if we wanted to, they're not going to ask that today. We have 3 ordered pairs. 1, 1.5, and 2, 1. Could we then graph the line? You need at least 2, but 3 is best, just in case one of them is off, because if you had 2, but the third one's over here, you know something is amiss. So we like to always do 3. Could we have chosen any other points? Yes, we could. I mean, countless, infinite number of points. All right, last thing there. Example 3 on 350. It says Don spent $13 on pens and notebooks. Pens cost $2 each. Notebooks cost $3 each. How many of each did she buy? So we know pens, $2, notebooks. Oops, the other way around. Pens are $2, notebooks are $3. In total, she spent 13. So do we know how many pens? So we could say that's P, but it was $2 per pen. Notebooks we don't know, so it's going to be $3 per notebook, and together the total was 13. So now we could come back over and do it like we did here. We can make a chart. So erase this one. This is one where it's called more guess and check. Eventually we're going to give you methods to solve it. For now, they want you to do guess and check. So again, the chart is like this. We're going to start with 1, 2, 3, and 4. So if we chose one notebook, I mixed them around. There we go. Pens and notebooks. No, I didn't. All right, so one notebook. So 3 times 1. 3 times 1 is 3. So we have a 2-step equation. We're going to get rid of our 3. So if we divide, P equals 5. These both came out to be whole numbers. So is that a viable solution? So if we bought one notebook, we could buy 3 pens. So let's try then for 2 for notebooks. Oops, I erased the equation. 2P equals. All right, so 3 times 2 equals, so 3 times 2 gives us 6. So we're going to subtract 6 so as our first step. Divide by 2. P would equal 3.5. We buy 3.5 pens, so that one's not going to be a good solution. Let's try 3 for notebooks. So 9. So we could get 2 notebooks. Is that a viable solution? 3 notebooks and 2 pens. Yes. All right. So now, if we put in 4, you think we're going to get another one to come out evenly? No, we found our 2 is what it's possibly going to be. So, all right. What I want us to start with today, 351. 9 to 19 odd, 29 through 39 odd. 9 to 19 odd and 29 to 39 odd. 351, 352. 2 word problems. Even if you're struggling with the word problems, nothing else. Do guess and check. Pick numbers. just start making a chart, see if you can make it work. Like I said, over the course of next week, we'll give you different strategies to help you come up with a better way.